Hello, welcome back to another video on JD's class. Today we're going to be looking at 3 common examples on SOD. So we're looking at common basic examples that comes out regularly in SOD. The first one is finding the unknowns in SOD. The second one is a combination of simplification and rationalization in one example. And the third one is SOD based on imputation of values. Now I'm going to be explaining more of that in this video. So now let's go to the first one, finding the unknowns in SOD. Now, a lot of SOD examples you're asked to find the unknowns. For example, given that root 1 to 8 plus root 18 minus root k equals to 7 root 2, find k. So we're asked to find k. Now, the basic thing you need to understand is that finding the unknown in SOD is just like finding the unknown in any simple equation that you have when you have to find x or so. But looking at this question, you notice that there's actually one thing you have to do, which is you're going to simplify before you find the unknown. So we're going to simplify root 1 to 8, and we're going to simplify root 18. But if you followed our last video on simplification, you should be able to find the simple form of root 1 to 8. Now, the basic idea is think of two numbers you can multiply together. One has to be the highest perfect square number that can go into 1 to 8 evenly, and if you multiply them you get 1 to 8. Now if you're thinking about perfect squares, 4 times 32 can give you 1 to 8, but 4 is a perfect square, but it's not actually the highest perfect square that can go into 1 to 8 evenly. 64 times 2 goes evenly, and actually 64 is the highest perfect square. So we're going to use that. So we're going to replace 1 to 8 with 64 times 2. So let me just put this like this. Okay. Then root 18, obviously we're going to see that 9 times 2 works perfectly for this, for us to simplify it, because 9 is the highest perfect square that can go into 18 evenly. And we're going to have root k here equals to 7 root 2. So simplifying further, we're going to have root 64 times root 2, root 9 times root 2 minus root k equals to 7 root 2. And finding the roots of 64, we're going to have 8 root 2 plus 3 root 2 minus root k equals to 7 root 2. Okay, so I've gotten to this point, and the next thing is for us to find like terms. If you notice, this, and this have the same SOD form, which is root 2. So we're going to bring them together. So we're going to have 8 root 2 plus 3 root 2 minus 7 root 2 equal to root k. Okay? So now that we've gotten this, you notice one aspect of addition and SOD or subtraction is that when you have the same SOD form for each of these values, you leave the SOD form in place and add or subtract the exterior or outer natural numbers. And that's the same thing we're going to do. So we're going to have here 8 plus 3 minus 7 root 2 equal to root k. So this is obviously 4 root 2, because 8 plus 3 is 11 minus 7, 4 root 2, so this is root k. Now at this point, how do you find k? Remember, we're asked to find k. So how do you find k? Okay, we're going to find k by applying one basic rule, which is for us to find the square of both sides, because that will help us have just k on this side. So if we're going to find the square of both sides, we're going to have 4 root 2 square here equal to k roots here. We're going to have square here, and this square is going to cancel the root out, so we're going to have 4 square and root 2 square equal to k, and which is actually k. Let me say therefore k is equal to, this is 16, and this is, and this square is going to cancel the root out, so we're going to have 16 times 2, which is 32. So it's that simple. So all you just have to do is follow the principle of finding unknowns in any basic simple equation, and then you can do that here. But remember that the those roots, those having the same roots, add and subtract in this way that we just did here. Okay, so that is about finding the unknown. Now let's go to the next one. So now in this one, we're asked to simplify 3 root 12 plus 10 root 3 minus 6 over root 3. Now if you look at it, you see that it is a combination of simplification and rationalization. We're going to simplify root 12 and we're going to rationalize 6 over root 3. So now we're going to do that immediately. Remember that these are the basic things you need to do if you have combinations like this. The other ones just stay in place. So we're going to have 3. The simplified form is going to be 4 times 3. You notice this is the highest perfect square that can multiply, that can go into 12 evenly. So we have 10 root 3 here, minus, and then we rationalize this to give, rationalizing this, we have 6 over root 3 times root 3. So let's come back to this point. So we're going to separate these to have 4 here times root 3 here plus 10 root 3 minus, this multiplied by root 3, 6 root 3. So this is over, 2 roots multiplied together is going to give us a square that will cancel the roots out. So we're going to have root 3 here. I mean, just 3 here. So you understand that? We've covered that in our last video, in our first video on Saturday. Okay. So, this is going to give us 3. The root of 4 is 2. So we have 2 here. Times root 3. We cannot simplify root 3, so we just have 10 root 3 here. And this natural number and this natural number can cancel out since they are not odd form. So this is going to give us 2. So we have 2 root 3 here. So this is a multiplication sign here. So we have 3 times 2, which is going to give us 6 root 3. Plus 10 root 3 minus 2 root 3, and they have the same root, so it makes it easy for us to have something like 6 plus 10 minus 2 root 3, which is obviously going to give us 14 root 3. So this is it. This is the answer. So it's just basic principle. I'm just showing you examples and how you can solve them. So if you follow the principle, you simplify, you rationalize, you just take it step by step, and then you get the right answer. Don't forget to rationalize and simplify the correct way. Now let's go to the most important one, sort by imputation. So in sort by imputation, why I basically called it sort by imputation is because you basically have to impute values into the main question for you to get the right answer. So if you have given that 1 over root 2 equals to 0.707071, by how much is 3 root 2 over 2 greater than 1 over root 2? Now we have this value here. This is equal to this. Now they want you to find this value and how much it is greater than this. So basically we are going to make this into a decimal form like this too. But how are we going to do that? Now you notice that 3 root 2 over 2 is the same thing as 3 over root 2. Now you may ask how. This is the rationalized form of this. Because if you multiply top and bottom by root 2, you get 3 root 2 over 2. So now it takes a lot of thinking for you to understand that. Now once you've understood that, you understand that 3 over root 2 is the same thing as 3 times 1 over root 2. Okay? So now once you've gotten to this level, you actually are on a good path to get the answer. So now getting this point helps you to understand that you're going to impute the values for 1 over root 2 here to find the real value of 3 root 2 over 2. And that's exactly what we're going to do. So 3 times the value of 1 over root 2, which is 0.7071, is going to give you, actually, it's going to give you 2 points, I think, yeah, okay, yes, 2.1213. You can check your calculator. So that is exactly what 3 times 0.7071 is. So now, once you've gotten to this point, you found the value of 3 root 2 over 2. But the question is different. It says, by how much is 3 root 2 over 2 greater than 1 over root 2? Now, all you just need to do is to you're going to remove the value of this from this. So the value of 1 over root 2 is 0.7071, and the value of 3 root 2 over 2 is 2.1213. So we're going to have 2.1213 minus 0.7071, which is going to give us 1.4142. So this is by how much 3 root 2 over 2 is greater than 1 over root 2. So that is all for the video. You have seen the 3 common examples that actually comes out in SOLD. Our next video is even going to be more interesting than this. So check it out. If you like this video, give us a thumbs up and also subscribe. Thank you very much.